I think Kirsten.
It's time.
Yep. All right, I think we're going to get started. Good morning. This is the SUIT working group. An IETF. No. SUIT? This is the SUIT working group at IETF 102. If you're not here for SUIT, you're welcome to stay and join us. This is the note well. Please note well the note well. So we have a few administrative tasks this morning. We have Jess, who volunteered to be one note taker. Can we? Thank you. Can we get a second note taker? We also need. Do we have a Jeff? We have a Rich. Thank you for that. A second note taker. We'll happily wait. Okay, that would be fine.
Thank you.
There's also Jabber information, Meet Echo, and Etherpad. If you're interested, I think Jess is taking notes in Etherpad, so you can join her there. This is our agenda for the day. Any agenda bashing?
We didn't request 2.5 hours.
All right. So before we move on with the agenda, I just wanted to give a really brief status report. So we've adopted the architecture and information model drafts. Thank you to the authors for all their work on that. On June 6th, we held a virtual interim where we focused predominantly on the architecture and manifest drafts. We generated a lot of comments out of that, and work is progressing on those drafts. And the minutes have been posted, so if you missed that meeting, feel free to check out the minutes. We also had a hackathon project, both at the interim as well as at the IETF 102 hackathon. Hannes will be giving us an update on the IETF 102 hackathon activities later in the agenda. So we're doing fairly well on our milestones. We actually managed to close out our first few around adopting an architecture and information model draft. We still have the serialization format to adopt. We're probably not going to get to that today, but we will likely have a virtual interim in between this and the next one, the next IETF meeting. So I think a focus of that might be to work on adopting a manifest serialization format. We have a milestone to submit an information model to the IESG. So we'd like to really focus our efforts on that, as well as a missing milestone, which I think we need to add, which is submit the architecture document to the IESG. So yes, exactly. So if it's okay with the working group, we would like to submit both the architecture and manifest information model to the IESG. So we'll go ahead and add that milestone, and we'll focus on those two topics today. Once we can stabilize the information model, it'll be easier to consider manifests. So all in all, we're doing, I think, fairly well on our milestones. And I think that's it. So on to the hackathon. Thank you, Hannes.
Yeah, I will keep this very brief. So this was from last week's hackathon. So a colleague of mine worked on a board that we used, and you can have a look at it over there if you want. But the purpose of generating this custom hardware was to use it as a sort of reference design to play around or to work on the different use cases that we have identified. Some of the more, so all of the boards support the basic use case for the firmware update, but we want to also have the more sophisticated ones where you actually have, and you see it over here, there's a, well, probably you don't, there's a external flash, so push it to the external flash rather than the on-chip flash. There are multiple MCUs here, so that's nice. A hardware crypto module with ECDSA support, NIST curve, and so on and so on. Also the possibility to connect to other ports if you want to have an off-chip or off-board microcontroller. So a couple of different use cases that we are going to talk about later on in one board. So that's, I think, quite useful. And that's what we have been playing around with at the hackathon itself. We had several new people, new in the sense of new to the IETF, but also some of them were new to the hackathon itself, so first-time hackathon participants. And I would encourage you to use that opportunity also at the next meeting, not just because maybe you are a little reluctant to get into sort of like such a hardcore topic from an embedded space, but I think it helped the participants to also then get familiar with the embedded development with the help of the others on the table. So I think that's Hemi has been great in supporting the newcomers, and he produced an excellent write-up, and you can see the link later on. So I think it's even if you are relatively new to the suit work, I think that's something 1.5 days well spent where you actually take away a lot of info and the board as well. So we can play around with it later on. So join us. This is what we produced. There's this detailed write-up. Take a look at it. I won't go into the details, but we tried to come up with different manifest formats, sign them, and sort of go through the whole chain and then verify it on the board. A lot of fun. What was learned? So actually, I believe we learned a couple of things. One is probably we need to do a little bit more homework before going into this hackathon next time, in having everything, the whole development environment set up already ahead of time, so we don't spend half a day more or less to just install stuff. So that would obviously be useful. So we'll take that into account. The new hardware was required some learning curve. On the coding side, I think we are not quite there for a reference implementation, in my opinion. So we have from the last London hackathon to this one, we now have a COSI implementation, which is awesome, produced by the Inria guys. Unfortunately, there's some licensing issue for some of them, so we are going to release another COSI implementation with a different license any day now. So hopefully that will satisfy the needs for some of you. But also the CBOR implementation, there's a lot of stuff there that can be sort of stripped down, and maybe there's a possibility just for a very constrained CBOR implementation only for these bootloaders. So we'll have to look into that. The spec itself, as you all know from the discussions on the list, there have been lots of changes, and I will get to that. And that obviously made it more difficult to work during the meeting. The API of the tiny CBOR implementation is also everything but intuitive. So there's some pain there that you need to go through. Just to give you a flavor of it, so you traverse the different objects in this CBOR structure, in this manifest, and you read something, you advance it, you need to say, oh, go jump to the next object, and that's okay, that's fine. But then there's some read operations that automatically advance. So you have this sort of like somewhat inconsistent behavior. So sometimes you have to advance to the next item manually, to the next element, and sometimes not. A little annoying. And there's no easy or no obvious, or not so obvious on how you would traverse some of the data structures. In the end, that was good. So we the participants thought that was a cool project, and so we won a prize. Thanks to the participants who voted for us. Nice picture in the end, so that's great. What's next? I believe what we could, and that's not just my thinking, what we could do is, as we advance in the manifest format, we'll have to keep up with the code as well. So that would be something to do already maybe ahead of time before the event. Also the COSI libraries, which I mentioned earlier. And then finally going into some of the more advanced use cases, since we now have the board encryption. Russ has this post-quantum based thing. Maybe that's something to look into. So there's definitely also for students who want to do some projects, I think there's something there for them to look into, also performance, energy, power consumption, et cetera, et cetera. And have you, some of you involved, please join us and talk to me and figuring out how to be active there and what, how you could contribute.
Do you intend to have a hackathon for 103?
I think so. So I hope that my coworker Brandon will come along next time as well, and so we can sort of split a little bit. I want to work with Dave on the deep stuff next time, and Brandon may be able to lead the effort on the suit stuff, so we can sort of create something bigger. So that's the plan, but sort of a little bit of organization and also finding out on who is actually going to be in Bangkok. It's not around the corner. So
maybe we can start some discussion about that on the list.
Yeah.
Thank you for all your work with the hackathon.
Yeah, it was a lot of fun. Yeah. Still have to figure out how to unbrick the boards that we bricked. Okay. Should I just continue? Well, I don't know if am I next on the agenda?
Yeah.
Okay. Not waste time. You mentioned it. Yeah. Okay. Architecture document. So there were, as Dave Woltermeyer said, that we had the virtual interim meeting, and for that one we submitted, in preparation of that, we submitted the 0.0 version, which we discussed back then. So I'm not going to focus on those changes again. But there have been a lot of changes on the document and also in the 0.1. So we tried to come up with new terminology, and I'm going to talk about that. And hopefully we can settle on this, because that obviously led to lots of changes in the text. There was a desire to sort of change the description for the operating modes, and I will talk about that briefly as well. I hope that's also a satisfactory direction. We had a few examples provided by David Brown, which I incorporated. He's also became a co-author for his text contributions, and there are lots of editorial changes. The entities that we have now there are the author and the device. So the author is the entity that creates the firmware and the manifest. Explicitly point out that there are multiple authors potentially, because we have on a single device, there may be, as mentioned before, there may be multiple microcontrollers. Even within one single microcontrollers, you may get software from different sources. So I'm trying to highlight this fact. So then, and that's a terminology we sort of like took a little bit over from the IETF. Dave Taylor suggested that a little while ago, and I've been trying to find a way to best incorporate this. So this communicator is a component of the device that interacts with the firmware update server. It basically receives the firmware images and triggers then the reboot, the update of those, and start up the new image. There are different ways it can interact. It can boil, or it can get a notification, and sort of more a push versus a pull mode. And there's also some text in there that talks about that in a practical deployment, this may actually be a little bit more complicated, because there may be multiple images that you need to download, because there's some dependencies and so on and so on. So take care of those cases as well, not just focusing on the most simplistic one. There's a status tracker, which is a little bit it's part of the architecture, but outside of what we are currently standardizing. So this is a sort of a device management functionality component that keeps track of the firmware update process, and it knows what firmware is installed on the device and what sort of state in the update the device goes through. It's a common component that people deploy in these systems. And so it allows fine-grained monitoring of changes in the whole fleet of devices that a device operator would use. And I will show a figure later on how these different boxes fit together. The firmware update server, as quite unsurprisingly, stores the firmware images and the manifest, and there may be multiple of them, even along a chain of sort of communication path. There in this device network operator, that's a new terminology that we added. The device operator is sort of responsible for the day-to-day operation of the IoT devices versus the network operator, who is really about operating the network where the IoT devices are connected. And we introduced those because we were in discussions at the Intra meeting and also at the London IETF meeting. We were talking about the cases of what is the level of influence and authorization or permission decisions that those entities take when deploying a firmware update solution. And that's also documented in some of the threats and use cases. So it was necessary to introduce those. Frank from Nordic Semiconductor suggested also to add another entity. He called it the OEM operator, where OEM, as the name indicates, is sort of the entity that builds a specific component. So you will, this was a little bit buried in another email thread on the human, the human rights review. So it's a little bit less visible, but I think it's worthwhile to brainstorm a little bit about whether we need to have a terminology for the OEM in this whole picture as well, to distinguish between the guy who's running these or maintaining these devices and someone who actually builds the different components. Not yet in the document, obviously. So if you have some perspective on this, let me know. And then, and that was really the difficult part, is how do we actually separate the communication architecture from the whole keying infrastructure and the authorization infrastructure? And there I introduced what I called, couldn't come up with a better name, Trust Provisioning Authority. And what it does is it distributes trust anchors as well as authorization permissions to the different entities. So, so when you think about the case where a device gets produced and that manufacturer decides that it wants to delegate the rights for making changes to the update to some other party, or if a network operator needs to do another signing and authorization step so that the devices, he wants to make sure that certain devices are only running in his network, there's some sort of orthogonal infrastructure that has to exist that besides the communication infrastructure. And I'm trying, not with a figure, but mostly with text, explaining that there's something going on here, that there's permissions distributed, and maybe there are some examples that we would have to provide in there to make this more obvious. Does that make sense?
Carsten Bormann, yeah. I think that the couple of slides, of the last couple of slides you have presented, kind of indicates that there are two different problems that need to be solved. One is the manifest that we have been talking about here, but there's also a need, at least in many situations, to actually describe the set of players and what specific authorization function they have in the overall flow. Mm-hmm. And that's maybe a good follow-on thing we could do in this working group or a different working group. A device that has a certain role in such a flow, in such a sequence of operations, can find out when it has to do what. So we have a sequence of processors in the manifest right now, but that's a bit weird because it comes from the original source. So yeah, maybe we can discuss this in some more detail at some point.
Yeah, well, this text was added and this entity more in response to discussions we had earlier, because we were trying to say, okay, the author of the firmware, it adds the manifest and obviously it assigns it, and somehow the key that it's used for signing, it needs to be verifiable by the device, but then we added on the possibility that the network operator also signs or some other party signs, and how do you take care of this? They don't create any new firmware, they just create new manifest and provide this authorization. So how do we deal with this? And the stuff that you mentioned, the changes on the manifest recently, they were added much later.
Yeah, so essentially there is something like an overseeing principle for this device, and that overseeing principle decides on which steps are required. And one or more manifests may play a role in that sequence of steps. And we cannot expect the initial manifest from the firmware author to elaborate those steps. That's what the overseeing principle has to provide.
Yeah, that's fair. I expect in most cases, sort of the story is fairly, or the processing steps and the trust chain is fairly simple. But of course, there may be some more elaborate cases. So maybe documenting them and then figuring out what to do afterwards is a good idea.
So Eric, not Mark, have you guys actually thought about what are the different use cases for this? Because I think that in the past there's been other ones that have come up, like what happens if the manufacturer went out of business, and how can you actually sort of insert things in here? So there's that aspect. It's also that if I can break into this part of the system, I can give any device any trust anchor I want to. So it operates at a different level from a security threat perspective, right? So is there any of this sort of larger pieces actually written down from a use case perspective?
Yeah, there are various use cases described in both, more so in the information model document, that deal with sort of threats or problems that relate from the different trust chains, where, so let's say, more focused on the operational side rather than the worst case where companies go out of business, and which in general is a sort of a little bit of bad case. Oh, okay. So maybe let Brendan talk.
Yeah, because one way of architecting the system is saying that, okay, a device will have one or more trust anchors. There might be a separate process of being able to update those ones, right? Adding, removing, whatever. But that could be separated out from the core, okay, this is how I drive the software updates, and then have a separate one under different security concerns about what does it mean to reassign a device and give it new trust anchors through its life cycle.
Go ahead, Brendan.
So the intent, when I originally talked about it, of the trust provisioning authority, was essentially that it was going to be a mechanism that allows a user of a device to put some kind of trust anchor onto the device. The trust provisioning authority was intended to be the entity that we usually refer to as the OEM. The problem that we ran into was that OEM ends up meaning a lot of different things to a lot of different people. And so by putting this extra layer in, this trust provisioning authority, it starts to make a lot more sense. So you can imagine a white label vendor who's going to sell their devices, and they're not necessarily going to care what kind of software runs on them. And they're going to let their customers put their own firmware on their devices. In that situation, that white label vendor isn't going to want to have to assign trust to different users for different devices. So in that model, the trust provisioning authority concept starts to make more sense. What it allows the OEM to do is it allows them to provide a channel, and that channel is what's used by the customers of the OEM to put their own trust anchors onto the device, and then make the device no longer claimable, if you will, with those trust anchors. So the idea here is that the trust provisioning authority provides a mechanism by which trust anchors can be established on a device.
But So that sounds like, in my mind, you didn't finish manufacturing the device yet because it doesn't have basic software on there until it goes through this OEM, which is actually different than saying as part of its life cycle, it goes through resellers, it gets, reacquired because someone bought the building that it's in, whatever, right? I think they're very different concerns about the initial, I need to complete manufacturing of the device, which you actually need to do, as far as I can tell, in a Faraday cage, whatever, right? Where nothing else can come in and interfere with it because you have no security to build anything on it anyhow because you have no root of trust already installed.
I mean, there are mechanisms around that. This isn't about ensuring that this isn't a whole solution, right? This is talking about a channel. It's talking about a framework in which you do this. A device has to make decisions. Do I trust the person who's trying to give me a new trust anchor? And how do I trust the person who's trying to give me a new trust anchor? And I'm not saying that this is something that has to happen in a Faraday cage. There can be keys associated with this. I mean, the simplest way of managing it is to put, say, print a pre-shared key on the outside of a device and HMAC the thing you send to it. Then does it match that? Yes, then the person must be in physical possession of the device, right? So there are mechanisms that you can install to deal with that. The point here is that there needs to be a mechanism in place on devices by which trust anchors are installed.
I actually disagree, because I think SUIT can be perfectly successful by saying we assume that there is a manufacturing process, whether it happens in one place or in two places, where some basic software and a trust anchor is installed. And now I can go and update software on this device by someone who is actually trusted by that original trust anchor, right? Someone is part of the original thing. And now you can do software updates. You cannot do ownership transfer, but that's a different problem. So don't conflate them. That's my how I do it.
Sorry, let me one more thing I'll say on that. It was not intended to conflate those two ideas. The point of this is that there are two roles here. There's one role that's the person who writes the software for the device, and there's another role that's the person who puts the authority for writing software onto the device. And there's in no way is intended to say that those can't be the same people. This absolutely can be part of the same workflow. In fact, the trust provisioning authority might provision trust on the manufacturing line, and that's fine. The point is that that's not always the case, and we need to distinguish between those use cases.
Sounds overly complex. But...
Hi, Jonathan Hamill from CSE. I'd just like to mention, if possible, could we coordinate language with the Trust Anchor Management Protocol, existing RFCs with TAMP? In there is a management trust anchor, and the idea is similar to this.
Yeah, I actually thought about that, but the issue here is that it's not just about trust anchors. It's also about permissions. So one of the things that we talked about was there are different elements in the manifest, and there's a possibility to allow others to override some of those elements. For example, we had the use case where the network operator wants to override the place where the firmware should be retrieved from by the device. And so if that network operator is given the permission to do that override on that specific field, then this has to be communicated somehow rather than overriding other fields. And so I felt that using the trust anchor terminology also for this functionality seemed a little bit a long shot. I don't know.
Carsten, maybe one form of coordinating terminology is just to point to it and explain what's different.
Mm-hmm. Yeah, I tried to do that, but I will double check. Yeah. Okay, speed up a little bit. Getting to the operating modes. So we now have these three modes that I think Dave Taylor proposed, which is a client-initiated, server-initiated, and a hybrid update. In short, the client-initiated uses the communicator to talk to the firmware update server to figure out whether there's a new firmware, and be done with it. The server initiated is one where you can't just reverse the roles, because in a typical deployment, you have some NATs and firewalls sitting around. So it's actually the status tracker who knows, and as the name says, keeps track of the status of the device, knows what firmware versions are running on the individual devices, knows actually what devices are out in the field in the first place, and knows how to communicate to those, potentially because there's a long-lived connection with that status tracker. And then when that status tracker figures out that it has to do an update, it basically sends, interacts with the firmware update server to provide that update to the client. The hybrid update is essentially a combination of both, where it's, the client is given a pointer to retrieve the firmware rather than the firmware itself. That's sort of the three modes that have been added in response to the discussions we had last time. Is that good?
Dave Thaler, I remember at the intro meeting there was a comment on the terminology. I think there was some confusion around the term modes, which implied to some people that a device had to be capable of multiple of them. And so that's not the case here. This is, you can pick and choose or whatever. So maybe operating models or something like that.
Okay.
I think.
I can change
So
that.
in case anybody else here is confused, I wanted to preempt that confusion here. So.
I added a picture on the communication architecture. I think that's fairly easy in other than sort of like the trust architecture. So here's, if you listen to the description of the terms, you have status tracker, sort of talks to the device, keeps track of what's going on. The communicator on the device talks to the firmware update server, one or multiple authors providing firmware images to the server, and there may be multiple servers and maybe even a sequence depending on, for example, if you get it from a server, store it on a smartphone or tablet, and then push it on a device using UART or BLE or whatsoever. Maybe I could make that more clear. So based on the feedback from David, we added a few examples, and I think they quite nicely illustrate what we had discussed on the manifest document itself, but just in a use case example. He also provided links to existing hardware that does this. Of course, I omitted the links, but you can look it up if you want to even get more details. So this is the first one is, I'll very briefly walk through those in case you haven't been following the details on the list. There's SoC is system on chip. So there's a single chip on the device, and it's obviously the most simplistic case. It contains, typically in the same package, it contains flash and RAM and all sorts of other peripherals. And so there's only a single firmware image that needs to be updated, and it's sort of like the execute in place that David is often referring to, where he wants to sort of like not move code around on the flash because it's obviously consuming a lot of energy. So that's the most simplistic case. Then it gets a little bit more complicated when you have a partition on a device. Normally partition between normal and secure space. We've seen that from the deep discussions, and of course those exist also on these IoT devices. So there's a case where the CPU supports this scheme, and in general, the way how it works is the secure mode will then do the update, will then decide on where things go, and you need to figure out on what you're actually updating. So the secure mode may just update the image on the normal side. So there needs to be a way to indicate on like what are you actually updating, which part of the component. And of course, independently or potentially both of it. So you need to have a way to describe this in the manifest. A more complicated scenario is when you have a dual CPU that actually uses shared memory, and they access the data, so there may be still, or there has to be a mechanism to prevent, or to have some locking mechanism, but typically one CPU then controls the update process, and swaps everything out. So the other it's similar to the former model, but just separated out into two CPUs rather than one CPU having a secure, non-secure partition. And this is just having a sort of two CPUs doing these different tasks. He also provided a link to some IoT hardware that does exactly that.
So I'm sort of looking at these models, and
State
I've
your name,
seen-
Keith.
Oh, sorry, Keith Moore. I'm looking at these models, and it seems like that there's a lot of naivete here. That, for instance, I worked with a CPU that had a lot more non-volatile RAM that code would run out of than it actually had RAM. So when you're actually updating the firmware for this, you have to update it in slices.
Mhm.
And you have to update each one of those slices one at a time and have the thing keep running while you're doing it. And yet it's a single system on chip. It's it doesn't sort of fit the description of the model you have. That, for that matter, the notion of a system on chip encompasses a wide range of capabilities.
Mm.
And so, a BeagleBone is a system on chip fundamentally. That's basically, yet it runs Ubuntu and, can do all kinds of things. And you often have a need, in my experience, to update things in layers because, for instance, you don't want to pay the communications cost of updating the entire image of something, because if you're using cell networks or something like that.
Yep.
So I basically, I just want to say, I think this needs a lot of work, and I'm happy to contribute input, but I wanted to say something.
Yeah. Welcome. Yeah, definitely.
David is in.
Okay.
David, you're up.
Great, this is working. Yeah, I think one
We don't have volume.
is it okay, or do I need to adjust it?
No.
No. It's on your end, David. We can't hear you.
Very, very soft.
Is this better, or?
No.
Okay, let me,
Can you use Jabber?
If you post your comments in the chat, somebody can relay, but we can't hear you. We can see you.
I'll come back in a minute.
Yeah, it's very,
Yeah.
it's a very low voice, extremely low.
I'm gonna.
Yeah.
Okay. There.
Okay.
Hopefully you can relay through.
Yeah.
Jabber for the moment.
And then one other, you can read through the text in the document itself, which is more elaborate, but the other model is where you have a bus between the CPUs, and you need to indicate in the manifest on which CPU on the device you're actually updating, but it's not in the same sort of address space, if you will, it's just separate. We also had an interesting discussion triggered by review, human rights review, and I included a link here, which it asked for I provided a couple of comments, and I think the most interesting one that left after some feedback and some email discussion was really about the encryption of the manifest. I believe the encryption of the firmware itself got sorted out, and I think we have the understanding that we have to have the feature, but whether you use it or not depends on your deployment environment. But the encryption of the manifest is something that surfaced in other discussions, and I don't think we currently have that functionality. So that may be an item worthwhile to think about a little bit, whether we want that and whether there are some privacy implications in certain situations, or what benefits we could actually get from this. So I see it as an open issue that may require further debate. I don't know if anyone here has thought about this yet. It's a more advanced figure, but in theory, with COSI, the functionality would be there, so one could make use of it. Yeah.
Hannes? On the mail list, if you take a look, you'll see that the human rights review person was saying that when a device is easily associated with a human, that is when this becomes an issue. And so I think we need to recognize that, but at the same time, maybe not overcomplicate the entire architecture, because not all devices have that problem.
Definitely, definitely. And in fact, I would even go as far as saying many devices don't have that problem because the manifest doesn't include user information,
Sure.
but indirectly, there may be in some cases. So I think we need to study this a little bit further to figure this out.
I was just going to add that there's some proposed text on the mailing list around scoping encryption as a solid recommendation for the human kinds of use cases. So I would encourage everyone to take a look at that text so that we can sort that out.
But there was a lot of text more on the focus on the firmware encryption itself rather than the manifest encryption. But
Okay, go ahead. I'm in queue behind you and in front of the other two people.
Ben Kada, you're just pointing out that the distinction between devices that have an associated human and those that don't is kind of a fuzzy question. And
Yes.
we hear about all these issues where you can de-anonymize anonymous data sets and that sort of thing. So there's lots of sort of side channels, if you will, that can make this pop up more often than you might expect.
Yeah. So do we have a relay from Jabra yet?
Yeah.
Yeah. Okay. Then you're up next. And then I
Okay,
have you.
right. Yeah, this is from Gershabad. I think there are general advantages to encryption of the firmware image and manifest, but it's up to the working group whether the draft needs to set requirement levels for devices associated with humans or not. And recommends encryption of the manifest also because it contains device info.
So Dave Thaler, individual, saving the trip over there. If the goal is to allow it without complicating anything else, if there's not another convenient mechanism, right, you can always treat the manifest as like another encrypted binary. And then you decrypt it the same way you have the binary and then recurse.
we'll need further work. Next steps. So we still have to do editorial cleanup on the document and get some feedback from the working group. I also, from earlier discussions, there was a desire to have more text around the bootloader design and how it the implications are for the whole processing of this. So I haven't gotten to that yet. There's also a need for better align with the information model because the terminology, sometimes one version of the document lags a little bit behind. So those are the major items. I don't think, besides the one that I just mentioned, I don't think there are huge open issues with the document. I think it's among the three that we are discussing here. It's further along in the chain. Okay.
Yeah. Any other comments? Okay. Yeah, let's move on.
The information model. So version 1 was published in time for the deadline, and version 0 was published in preparation for the virtual intro meeting. If you look at the diffs, there are lots of changes, so I can't go through all of them, and some of them are probably a little out of sync with the presentation that Brennan is giving when he talks about the most recent version of the manifest format. So I'll skip those. I focus just on a few core issues. We added 2 threads regarding the unqualified firmware. So here's the case that was discussed and hopefully appropriately captured. So imagine you have device and network operators, and the device operator creates the firmware or has works with the author to do so. And then the network operator needs to decide whether this specific IoT device with their firmware is fit for purpose on that network, which may be a situation in some of the critical infrastructure environments. And the device operator manages devices that are deployed in all sorts of different networks. And so the attack scenario is the following. Imagine an attacker obtains a manifest from a device that is deployed in network A, and then he takes that manifest and sends it to a device in network B. So the device, it's fine for that device because it's managed also by the same device operator. but network A and network B are under different control. So implying that firmware update to this other network B, would be a problem, would be a violation of the policy of that network operator. So it's perfectly, like from a signing point of view, it's perfectly fine, but just not complying to the policy. The other cases where you have multiple devices that interoperate, they are working on the same network, so we have only one network operator rather than two, but multiple device operators, and you, so some of the devices are manufactured and managed by device operator A and others by device operator B, and now is a firmware release for device operator A that breaks the interoperability or compatibility with those of the device operator B. So the network operator may want to have some saying, or some may need to qualify which one of those firmware images are actually allowed to be used in his network, irrespectively of what device operator manages them, which can then obviously be used to cause denial of service or potentially other problems. So we added those two threads. I don't remember who suggested them, but I covered them. There's some. This is actually terminology from the architecture document, but because it's used in a subsequent slide, I would just want to remind you. So there's one case for the heterogeneous storage architecture where a device stores the firmware image or firmware component at least in different ways in the system. So, for example, you have a device that has on-chip flash and off-chip flash, so those would be stored differently. Whereas in the homogeneous storage architecture, we are talking about storage of firmware images or different components in the same way, so they may be just in different address spaces on the flash. So those two terms. So for the case with multiple microcontrollers, there's a need to have component identifiers to actually distinguish between the places where these firmware images have to go. In the case of a split between code and configuration on the same device, what the manifest needs to provide is sort of a dependency structure, because it has to sort of get the code and the data somehow aligned. So you can't just swap out one and not have any say anything about the other one that this firmware image then depends on. So this is sort of the dependency structure, whatever the name in the future will be. And then in some cases you have the firmware split into multiple chunks, maybe different libraries that you update separately, maybe for performance reasons or for bandwidth or conserving bandwidth. And so you also have to create a dependency between the different firmware images that you allow on a device. We had a few examples, and they are also in the document where we have more sophisticated cases where multiple different versions are sort of supported or are possible versus having only a very specific firmware version supported on a device. So we have those added, and together with those use cases, obviously the corresponding information elements added as well. I'm going to talk about them a little bit. There's one use case that David Brown suggested, the rollback use case, which is not yet covered in the document. So he has he came up with this case in talking to some others. It's about a battery powered device that is connected to a bandwidth constrained network. Think about the low power wide area network. And the device keeps the old firmware around just in case it needs to do a rollback. So it has multiple slots for the firmware image. And then the document doesn't say on how such an update would happen, because it always talks about advancing the firmware images and rolling. Obviously, when you advance the firmware image, you need to provide the new firmware image along with it. So he thought that it would be good to also describe this case where the rollback, the new manifest, which contains a new sequence number, actually doesn't contain the firmware image because it is already on the device. So and it's possible already with the way how the manifest is structured, but it's just not described and maybe a little misleading. So he thought it would be worthwhile to cover this case. So all you then in the end need to do is to send a manifest with the new sequence number pointing to the old firmware image. Maybe it works now.
Just wanted to point out, in this particular use case, the person doing this actually decided to not use rollback protection so that they could support this case, that it was more valuable to them to be able to roll back than the security aspects of the anti-rollback protection.
Yeah, maybe because they didn't know that it's possible, so it's probably useful to describe it and to make people aware of it. Yeah. So I think we should definitely add that use case or add this description.
And David, your audio was great that time.
Yeah.
Hi, Hannes. Robin Wilton from Internet Society. So just thinking of some of the security implications of this, it strikes me that having a rollback mechanism for large networks of distributed devices could open you up to a kind of downgrade attack. So if the purpose of the firmware upgrade was to add a security function, and someone can, at a mass scale, roll that back on all the devices, they open those devices up to be a botnet, for example.
In this specific case, I don't think so, because the entity has to, or the party rolling out the firmware update actually has to create a new manifest. The new manifest has a new sequence number, so it's newer than the ones that the device had seen before. But I think the optimization here is really in the area of not sending the image itself.
They got in queued at the same time. So.
Okay, Benjamin Dan. I assume the sequence number is not strongly connected to the firmware version, so that if you really had a downgrade attack that was that bad, you would increase the sequence number, but typically you wouldn't. I mean, we face a situation all the time where you have to downgrade and.
Correct.
Okay.
Brendan, you're up.
The intent with this mechanism is that it proves the intent of the author. So if the author says, actually, the firmware that's just been rolled out is not fit for purpose and we need to go back to the previous firmware, they have to prove their intent to go back. That's the defense against creating botnets. The issue in the botnet situation is that you don't have the intent of the author. If the author hasn't proven that they want to roll back, then you end up with a problem. If the author can prove that they intend to roll back, then that eliminates that possibility. Now, I'm not saying that they don't have vulnerabilities in their old firmware. They might well. But if there's an intent that you can prove to go back, then presumably they have a reason for that, and that is open to them. They could just create the same firmware again and ship it again, and that would give the same result. But this does it in a slightly optimized way. Well, maybe a very optimized way.
Okay.
Hi, Padu from, OMA. Okay.
No.
So in terms of this rollback, I believe, is there a need where the manifest is attached with the date after which that firmware does not have the veracity to live in the device and then it rolls back?
I don't think we have a date where you there's a date, if I remember, an element in a manifest where you could indicate on when you want to apply the firmware image, but not when it stops becoming valid. I don't think we have that element in the structure.
Okay, thanks.
I very briefly wanted to talk about the manifest elements. I will skip. I will be very brief because I want to give the time to Brendan because he has this new structure. So referring back to the discussion earlier with the different types of use case and different types of sort of more sophisticated hardware components. So we have this concept or this element of storage location, and which then allows you to distinguish, for example, are you updating an OS? Are you updating an application? This is sort of the two storage location case. Are you putting something on a file system? So that would be the path in the file system. Or are you putting something into flash memory? Where exactly in flash memory do you actually put it? This is sort of like the offset or address of the the space where you put it. So that's an element that has been added or has been clarified. There's also, okay, so that's good. There's also this component identifier which was added because in the case of heterogeneous storage architecture, this storage identifier that I just talked about is not sufficient to actually identify where to put the information, the firmware. So this component identifier was added as a new element. The conditions, and the condition element was there all along, but there was a lot of confusion and discussion. So on the different elements, and it was then later split into two types of conditions: preconditions and post-conditions. And that change has been made in a manifest format, but hasn't been populated back into the information model document. So you still have a little bit of an out of sync situation there. Carsten,
Bob, can you go back to the previous slide quickly? Sure. So in about half an hour ago, you said something that really intrigued me, which was part of a component. Okay. I cannot reproduce the entire sentence, but
okay. I can
maybe
try.
We have a little bit of work ahead of us here.
Okay. So probably the most dramatic change, which also is currently out of sync, is, and I included the link to an email here from Brandon on the list about the sort of changes on the directive aliases and dependencies, which had been turned into a new structure resources, and that text isn't there yet in the information model document. We'll get to that in a little while.
Hannes, can you go back to your slides? I don't think you finished your thought about conditions. What work needs to be done?
So the work that needs to be done there is to take the split or the decision to split the conditions into pre and post conditions, also reflect that into the information model document. Currently, it's not there yet.
Okay, thanks.
And this one is brand new, so this is also not there. And I think this is something the group hasn't maybe not even decided fully yet. So probably that's the reason why it's not there. This sort of combining several of those concepts that look very similar into one new element in the manifest.
Hi, this is Hank. Yeah, I was very curious about the resource processors, targets, input node, output node composite that was in there. I basically, because this night I submitted a map-based manifest as an alternative. I was really just copying that because I had no clue what the semantics were.
Yeah.
I mean, I got it a little bit, but this, yeah. Yes, you said it. There's a gap here.
Yeah,
Tiny.
Brendan is going to talk about that.
Excellent. Thank you.
In a second. So I will skip. So one of the things I think my lesson learned from sort of this whole exercise is that it probably wasn't a great idea to separate in the early stage the information model from the serialization format, because now you have all these inconsistencies from a document point of view, simply because reviewers like to comment on a more specific thing, while they should actually be commenting on the higher level abstract thing, but they don't, because we are engineers. So we like to write things down in a more specific style for some reason, and so you see things being somewhat misaligned. So if I would do that again, I would probably have just one document and split it later on when I actually figured out exactly how the structure looks like. But it's a little too late for that. But okay, and I hand it over to Brendan. Or any other comment? Yeah, sure.
So I didn't really, this is Hank again. See, does this required version thingy in the information model that didn't make it into the manifest at the moment, right?
There's a version number in the.
Yeah, but this is this there's multiple versions like major, minor, whatever revision, and then this is a prerequisite for being able to update that in a multi-segment or multiple partitioned firmware, each having its own precondition basically.
Yeah, that is the precondition concept that's there. I don't think the major minor version number concept is there. I have to look, and probably Brendan can answer that question when he talks about it.
But
it's not an information model for sure, because it just talks about version. It doesn't talk about
maybe
major
elaborate
minor.
on that a little bit.
Maybe it should talk about major minor.
Okay.
Yeah.
Thanks.
Hello, Stephen Banghart. I have a terribly boring question regarding both the architecture and the information document. The documents switch between uppercase and lowercase must, so it's kind of hard for me to know when I'm reviewing the document what you intend to be a requirement and what you don't. So if you could update your section 2 to use the new BCP on uppercase and lowercase requirements, that would be really helpful for me as a reader.
Okay.
Thank you.
That's a good comment. Yeah. So in general, I think, and Brendan will also talk about this, I don't think we have fully decided yet on what is the mandatory to implement elements, and so we will have to do that in some point in time. Yeah, the board, yeah.
Brendan, can you jump into the queue? Thank you. And go ahead.
Okay, so I want to start by saying that the manifest serialization is under a lot of flux. So for instance, there's this whole thing that Hank mentioned about the manifest processors and resources and targets, and I honestly now believe that that's probably a mistake and that there's a better way of handling it, which I'll talk about in a moment. So suggestions welcome. There's a lot to be done yet to get this to a point where I think we can standardize it.
Brandon, I have a customer one here. I have a terminology comment. The serialization is done. That's in RFC 7049. What you're really doing here is the data model, right?
Yes. Okay, so next slide, please. There are a lot of open issues. The first one, as Hank brought up, is should the primary object be an array or a map? Then there is the question of whether we should use a graph, as I described in Manifest 02. I'm not convinced, but if we use trees to deal with this, then there are open questions of how they're overridden, represented, and whether or not they break any use cases. There's also the question of whether we can have one type of digest for the whole manifest, or if there's a good reason to support multiple different types of digest at a time.
Can you elaborate? Sorry, can you elaborate on what your intended difference is between a graph and a tree?
Can you give me a few slides and I'll elaborate?
Sure.
Okay. Sections be severable. So we introduced the concept of severable text at we started talking about it during the hackathon at the virtual interim meeting. The idea behind this one is that we cut text out for devices that don't require it. Text is meant to be human readable. Devices don't really need to process it, and it can increase data sizes. So by making them detached, I believe is the term that's used in most containers, or most crypto containers, the idea is that text can be delivered to the entities that require it, but it can be pruned when a manifest is delivered to a device. We have an open issue that COSE has no algorithms no algorithm identifiers for digests on their own. So I think that we probably need to file another draft for COSE to add algorithm identifiers. Next slide, please. There are more. Encryption of the manifest is something that we might need to address explicitly. It's also something that we might need to address one level higher up, with the concept of severing more sections of the manifest rather than just the text. Maybe it's possible that we could wrap that particular problem up in one of the sections that the manifest references, while still maintaining the ability to process manifests at intermediate steps, which is important for routing considerations, among other things. We need to work out the encoding of processing steps, directives, and conditions, and extensions. And there's a lot of enums used throughout the manifest, and there are going to be IANA implications because of that. And with that list of open issues, shall we dive into a couple of them? Array versus map. I'm still more set on arrays than maps, largely because most of the fields are mandatory. I have yet to see a compelling argument to go the other way. If there is a compelling argument, I'm definitely open to it.
So, Carsten Mormon again. We had this interesting hackathon in June that Hannes talked about. And one piece of feedback that was pretty strong from implementers on the embedded side was that they really like to do pull parsers. And pull parsers essentially means that the control flow in the program that actually makes use of the data is kind of bound to the serialization sequence in which the data comes in. That, of course, means the more deterministic, the more predetermined the serialization sequence is, the easier it is to run this pull parser. That's actually an observation that's both relevant for this and for the next question. So for the array versus map decision, the obvious advantage of a map is that it's easier to extend. The disadvantage is that you are not predetermining the sequence. Now, you can do some things, of course. For instance, if you go for consistent encoding, you could say the fields in the map have to be serialized in a sorted way and so on. That's one way to fix this. But I agree with your assessment. Right now, this is a pretty stable set of fields. So why can't we put this into an array? And of course, we have to have an idea where we would put extensibility. And since I have to run away in a couple of minutes, let me quickly say something about trees. Trees are essentially to graphs what arrays are to maps. So trees again allow a pull parser to tie its control flow to the sequence in which things come in, while with a graph that may be more complicated. That's not always true because there are some elements of a graph that you would just stash away and then use in the following. So this is not quite as clear-cut as for array versus map. But as a general observation, I think trees are actually easier to process in an embedded implementation.
Hi, this is sorry. Hi, this is Henk again. And yeah, sure, of course, trees are easier. That's a plus. Also, I think out of 12 fields, 5 are mandatory and 7 are optional. I think it's the wrong way around. Also, I think why not do one thing and also not do the other? I mean, there could be a fixed envelope. We have one that is the COSI, where the payload resides, and maybe the payload is just the firmware, and we put everything that is about the metadata into the secure header, for example, just spinning from the top of my head. Okay, so we might be able to leverage both benefits of maps and arrays, and don't have to stick with one necessarily. I think. Also, I would agree with the idea that if you want to pull something out of a file and a distributed offset, you have some additional problems with padding, I think. It's like word-wise copy. I think that's brought up on the email list, I think. At least it was brought up at the IETF hackathon, Hannes. Maybe you can remember. I don't really know the source anymore. But there was this idea that we just blindly can grab into the manifest if there's a firmware in there and then put that out, because it's word-wise copy. I don't remember. But there was some very, very, very strict and naive requirements there. That's like, I basically want to do nothing. I want to be sure where it is when I receive it at the end. Maybe it will never be that easy, but I don't think that maps are such a big disabler for that, because at the moment we are looking if an array is empty, and if it's not empty, there's an array in it, and that might be empty. And that's also a lot of work. I mean, looking for a member is basically the same effort. So I don't think there's a huge, at the moment, a huge difference of efficiency here.
Whoa. Hold on. Dave Waltermeyer as an individual. Just to kind of touch on some of the points that Hank and Karsten made, I think my preference would be for using a map in this case for a number of reasons. I believe using a map will actually reduce the amount of branching. I don't like the idea of supporting both arrays and maps, because that's another source of branching in parsers. But I believe a map will reduce branching because the code points that are effectively used as the labels can be used to drive code, like Carson was saying, and pull parsers. I think it also gives us a way to add extensibility into the model by allocating additional code points for different kinds of information that we may want to include in the manifest in the future. If we get something wrong with our current representation of information within the manifest, it allows us to issue a new code point for maybe an alternative to that in the future, which I think also eliminates a lot of the need around versioning within the manifest. Effectively, the parser can work off of the code points that it understands from that perspective. So I think using a map has a number of advantages as a solution over an array.
Okay, so by the way, David and Brennan are back in queue, but since Carson, you have to leave, we're taking the chair's prerogative to let you jump the queue and then leave. So
just two quick comments. One, anything that can help avoid versioning, I'm always in favor for. And two, whether an array really gives you a lot of advantages over a map depends a lot on whether you can process these elements in isolation. If you need to see the whole picture anyway, then the map is fine. But if there's something that you then a map is fine, because it doesn't make a difference in which sequence you start processing it.
let's have conversations at the mic. So,
yeah.
Because
so
David and
what
Brendan
I
want to
was trying to say is an array is really beneficial if you can do processing without having seen the whole thing. If you need to see the whole thing to do the processing, there is no difference in implementation complexity between array and map.
Okay. David, you're up.
All right. First point I'll make just in response to that, in COSE, or actually CBOR, if you use a canonical format, which we should be using if we're signing these, the map will be in a specific order. It's sometimes a confusing order based on how the numbering system works. All positive numbers come before negative numbers, that kind of thing. And then it depends on the size of the number. I guess the point I wanted to make, perhaps it would be useful in our document if we actually identify the processing sequences that will happen. Especially this notion of a pull parser, that's a great way to describe, by the way, what I was trying to state, that the data needs to be parsed without reading it into a data structure. Some of these are very constrained devices that are acting on the data. And I think that needs to be really taken into consideration, perhaps even included in the document, how this will be processed. So that's just my comment.
Yeah, quickly intervene, because I don't really have to run. One observation, there is something called canonical encoding in RFC 7049.
Yes.
That's a recommendation, not a specification. It's a recommendation for how an application could define their canonical encoding. We are no longer happy with everything exactly that's in there. So we are going to, in the revision that's going on in the CBOR working group, we are going to define a slightly different consistent encoding. And the main difference here is that the new one will have a map ordering that's slightly less surprising. It will still have the negative numbers after the positive ones. Maybe that is a bug in the allocation of major types. But at least you don't have to look at the length, because that really hurts implementations a lot. Okay. The other observation is you don't have to be canonical or consistent to Sein. So you are free to choose anything else. But I think when you make your choice, you want to make life easy for the embedded side, and may want to accept some hardship on the side that actually builds the manifest. So putting more onus there and less onus on the embedded side is always okay.
Agreed.
Thank you, Doc. Just thinking about David Waltermauer's comment about using the map as an extensibility point. Generally, when you're thinking about the sort of extensibility thing, you want to consider the possibility that a new extension might be critical, and that if it appears and you don't understand how to parse it, you just fail entirely. I'm not sure if there's a good way to incorporate that with the Cosine map or not, or the CBOR map.
So hi, this is Hank again. I'm just picking up on the previous comment. Yeah, it's bad if you do not do updates before updates. Because if you're totally unprepared for something that's in the manifest that should be supported by the client, you staged something wrong, I think. So please build good campaigns. That's important, or there will be losses. So, and that's one. Also the map thingy. What was my point? Yeah, the canonical ordering is an option, I think. And yes, everything that makes it less necessary to look for versioning, and the new canonicalization of CBOR will also reduce the need for looking for length in values, makes life really, really easier. And what was mentioned before about that you would like to have a pointer to something from the manifest and not a copy of it, because a small constant node device would benefit from that. That's just a tool problem. That's not the problem of either maps, arrays, or the suite manifest at all, I think. And I think tiny CBOR cannot just do it, just copies it.
Brendan, you want to get back in queue? Brendan is still on Meet Echo, but not in queue, so. Suit to Brendan, are you still there? Oh, here he comes. All right.
I was trying to sort out becoming a presenter with Meet Echo. I think we may have it now. Yes, so I take the points that are made. I particularly like the idea of pull parser, and I think that one thing we might be able to do here is try and actually merge these two concepts. So what I mean by this is that if we deliberately flaunt canonical encoding and put elements in the order that is needed by the target device, then we can actually get perhaps the best of both worlds.
like David Brown wants to respond to that. So Brennan and I have to move on to let David speak. So
yep,
please jump right back in queue. David, go ahead.
It's one thing I pointed out on the CBOR the CBOR mailing list. In the manifest that we currently have, we use a syntax that is allowed by the grammar in the CBOR spec, but not explained what it means, which is basically an array of pairs that may be a useful format. It's basically treated like a map, but the ordering can be specified. So I don't know if that's useful to contribute to CBOR in that regards.
Hank doesn't think so.
Back to Brendan.
Yeah, I mean, maybe that's something to contribute back to CBOR, but I think treating it as an array of pairs might be the right answer, and I think that we can probably handle it that way. Yeah, I like the idea of deliberately reordering maps rather than sticking to a canonical encoding.
And this is Hank speaking as an author of CDDL. Yeah, you could use this two-dimensional array, but they're maps.
Should we move on to another open issue?
Yep, let's keep going. Right, so as Hank mentioned earlier on, the information around what exactly the process description is a little bit thin on the ground. So this all comes from a fundamental requirement for a device to be able to assess whether it can process a manifest up front. If it can't assess that, then there's no point in having separate metadata from payloads. So the intent is that a device can determine exactly what it needs to do to process the content that it's being provided with. And for that, it needs to have a description of exactly what it's going to do. So if we start by moving things that are things that are installed into their own section, then what you need to describe them becomes quite small. Likewise, if you describe how to obtain that thing that you install separately, you need to specify where it goes so that you know which thing you install you're referring to. And the most sensible way of doing that, I think, is to put the same component identifier in both sections. Then you need a list of steps that you have to go through to process these devices or these things you install. This could include things like decryption, decompression of multiple kinds, including things like Delta, which is a little bit more complicated since it requires 2 inputs. And then finally, resources, things you refer to that contain firmware, payloads, what have you. Those need to have a URI or a component identifier in the case of a Delta input so that it can refer back to something that's already local. On to the next slide, please. So here's a fragment of CDDL that explains roughly what I'm thinking of doing. You have this thing called an asset, which has the component identifier, an explanation of how the device is encoded, any parameters that it might take, the size of the resource, and the digest for the resource. I should go back and say that the encoding really needs to change to an enum, but that still needs to be discussed in the working group and exactly which kinds of encodings we'll list under there, which is why it's still a B string. The parameters need to be a B string to deal with individually defined encodings. The component identifier I've got listed as an array of B strings. Following on from discussions at the hackathon, I've come to the conclusion that a component identifier and a storage identifier together are just a generalization, or sorry, they're a specialization of an array of identifiers. So let's just use an array of identifiers. Then this can be thought of as a path, if you will, but it's a machine processable path. So you can imagine a Unix path, but instead of having slashes between elements, you have a CBOR array, which is easier for a device to parse. Then there's the digest, taking in the feedback from the list that you may want to have more than one digest algorithm in a particular manifest. This approach to digests has a digest identifier for every individual digest. Next slide, please. All right. So this explains how a particular thing that you install gets installed. You start by having a component identifier and then a list of processors. Now, processors are things that manipulate the data in some way, either by producing it, if it's the resource type, or by decrypting, decompressing, undelta, relocating, all of those sorts of operations. Now, because some of these can happen together, there's a list of inputs. Now, those inputs can either be a URI list if they are remote resources, a component identifier if it's a local resource, or a map of inputs if it is a non-resource type. So this is, for most of these, it's relatively straightforward. Decrypt, for example, would take one input, whereas the undiff, or I guess undelta, would take two inputs. And the reason for the map is so that it's clear to specify which input is mapped to which index into the array of processors in the asset installation info block. Allow override tells you whether the asset installation info can be replaced by a dependent manifest, and extensions, as previously discussed, may not be needed if this is re-encoded as a map. Next slide, please. So why not leave container information in the payloads? It's so that we can reject the manifest if a device can't process it, and this is particularly important for low bandwidth. And not using enums for aggregate formats is largely due to the specialization that's necessary to do it. Each of these different blocks would have to have their particular arguments supplied, and that leads to the possibility of many different configurations, many different structures that need to be registered, whereas breaking them apart makes it somewhat less complicated.
Brendan, I'm sorry to interrupt. This is Dave Waltmeyer. I had a question on the previous two slides, actually. If you can go back one more. So on relating to the component identifier here, have you put any thought into how you might namespace component identifiers to avoid collisions? It may make sense to have some namespace identifier and component identifier instead of concatenating them all in a single B string.
Well, indeed, that's why this is an array of B strings.
Well, I mean, but how would you identify an individual component identifier, the namespace of an individual component identifier?
That would be the, okay, so in that respect, the component identifier, as I said, you can think of as the entire path to a particular component, to a particular thing that you want to update. So the namespace would presumably be the first element. It's not quite the same as an OID, but it is somewhat similar. I will give you that.
I see. Okay, yeah, we should make sure we're clear about how that may be used. And then can you go to the next slide? So under type, is the intent here that the negative int is used for extension?
That's correct, yes.
One option here might be to use to maybe provide for specification required or standards action for one type of extension and maybe private use for another. So you might want to maybe use like positive values for specification required and negative integers for private use. We should maybe think about how this extension point might be used a little bit, going forward, and how we might want to manage those extensions. And maybe that's a general comment too. For all places where we have extension, we probably want to follow a common pattern just to make understanding that a little bit easier.
I agree. The pattern that I have suggested so far has been that negative integers are used for extensions and positive integers are used for registration.
Gotcha. Thanks.
Hi, this is Hank again. Okay, looking at this slide right now, I see extensions. That's fine. It's a map that is basically everything, and it's huge. And there's also the idea of having a CDDL extension point. So this is for, I think, doing it quickly by yourself with negative numbers, for example.
Yes.
And if you want to do with the positive numbers, maybe indicate that you should do a CDDL data definition extension and not just arbitrarily fill more stuff into the extension map. Because that's not well defined. At some point, if you're really going for an extension of the manifest, you should write a draft about it and use the CDDL data division language extension point and not the actual map here. I think that's important to highlight. Also,
yeah, I agree.
Also, I think you have only one member in the inputs map. And I think you said that you want more than one here.
Yeah, so you're right. Although URI lists are significantly more than one input as a possibility. You only select one of them, but there's a list, so there could be more than one.
Okay, so that's one of the potentials. Okay.
And the other one is the map of inputs. Now, again, that is a specialization that deals specifically with delta updates or differential updates. And that's because you need a local input, the thing that you're comparing against, and the remote input, the stream of differences.
Okay, I get it better now. Thank you. Then reading processor, I'm pretty sure that in the main array, it's not called processor, and CDDL does not really compile it. I tried to compile it this night, and there's some, I don't know, name discrepancies.
Yes, there were some name discrepancies, and I believe I have dealt with most of those, but I haven't published the updates yet.
Okay, excellent. You can't see, can you see my thumbs up?
Yes, yes I can.
Okay. Also, if I remember correctly, there is an enumeration here, resource decrypt, this is all integer values, fine. And you continue this enumeration across different semantics, I think. They're only getting larger and larger. Is that correct still? If I'm just looking at the current submitted draft. So
I believe that they are restarted for each different semantic.
Okay, maybe I have it wrong from the top of my head. I will check, but I think they are continuous over semantic types. I think.
Okay, I believe they all start at 1. If there's a good reason to start them to restart them, then that's another question. So an example here we have a raw binary payload, so there are no arguments needed. Then an encrypted binary payload is the next possibility. You would need a key identifier, an algorithm identifier. Those would both need to be arguments to the payload descriptor. Then the possibility of encrypted compressed binary or encrypted compressed delta payload. You can see how each one of these has a different set of arguments that are needed to describe it properly. And when we go through this, this is essentially my justification for not defining aggregate payload types as enums, because with each of them, a new structure would have to be redefined to encompass all of the arguments that would be necessary to process that payload. Next slide, please. There, I've already said the same thing. It would be easy to miss a reasonable combination of supported steps. So I'm suggesting that we describe each step instead, and each one can have a defined structure. They can all be represented in the same way, but then we have to define how flow is described. And because of delta, we know that flow is a tree rather than a linear sequence. A shared resource between two steps might turn that flow into a graph, but as was mentioned earlier, graphs make constrained processing hard. So using multiple trees instead is probably the right answer. And I haven't seen a lot of examples of a shared resource. So, and even if it were, I don't think that would increase data size or make processing particularly harder. So I think it's probably the right choice to define the flow between these steps as a tree rather than a linear sequence. Next slide, please. So the way that this would be constructed together is that each asset would have a tree that defines the installation process, as I defined above. To reduce the nesting depth in the parser, the tree is encoded as a list. Now, this is important for early verification. It makes it easy for a device to check that it supports each of the processing steps that are defined without actually having to construct the tree or parse down a deep tree. The output identifiers are the index of the processor in the processor list, and the inputs are a map of indices into that processor list. Resources are also encoded as processors, but with no inputs, or rather with inputs that are redefined to either URIs or component identifiers. An asset is designated as something that has a single tree that feeds it, and the output nodes that I had mentioned earlier can be marked as non-overridable. That's where the allow override or allow alias, I forget what I called it, is in the CDDL previously. And again, dependent manifests can override any installation tree, and that's the whole tree that's not marked as non-overridable. Now this is to address a use case that was brought up in one of the previous meetings, where you have a gateway, for example, which will pre-process a payload for a device. Suppose that the gateway is the termination of the encrypted channel that is needed. Then your gateway can decrypt a payload for you and then send it on. But that needs to be represented to the device in some way. So in this case, it redefines the installation tree, and the device then can pick up the installation tree out of the dependent manifest and still validate the asset out of the canonical manifest. Next slide, please. So how this would work, for a raw binary payload, you would have a component identifier. This is to the explaining how it gets installed. You'd have a component identifier and a resource, and that would be all of it, the whole installation information section. The asset information would be exactly the same. You would have a component identifier, the encoding is raw binary, and what's not listed here, the size and the digest. Next slide, please. Here again, a Delta payload. Here we have two different processors. First, there's the one that provides, or sorry, there's the component identifier, of course, then three processors. One that is the Delta, which actually unpacks this, this update, then the resource, which is a list of URIs, and then the resource, which is the component identifier for the existing image. And then in the asset information, we'd again have that component identifier so that the device knows which, where to store this, and can link the asset information with the installation information. The encoding as raw binary, and the input node, I think, shouldn't be there, right? I missed a section I was supposed to delete. My apologies. There's an error in the slide. Please disregard the last bullet point. There would be an additional digest and size in that asset information as well. Next slide, please. Right, so that is the end of the material I've got prepared on the outstanding issues. there are any questions now, that would be good on the tree structure or any of that.
Hannes is coming to the mic.
For me, it would be interesting to know whether we sort of made a conclusion on going to the map structure away from the array. That was the first point that Brendan brought up. And the second thing is whether we want to go forward with this sort of processing structure that Brendan has just presented, because that would be obviously useful in going forward and refining it. We had a longer discussion on the mailing list on those topics. Or if there's a different direction, then probably would be also good to discuss this as we are going to move forward. As we update this data model document, we also have to then get the corresponding information model document in sync, dealing with some of the conditions and all the asset and the other things. So it needs to line up, otherwise it's very difficult to understand all the whole thing.
So the chairs were thinking that the way to go forward here would be to let the authors do one more update and then do a call for adoption. Does anyone think does anyone have a better idea? Okay, does that work for the author team?
That works for me.
Okay. Yeah, well, so the map versus array thing, I was thinking that we'd let the authors make an update, tell the list what they did, and then when we do the call for adoption, if everyone thinks it's right, we're okay. If they say it's wrong, we'll hear about it at that point. Does that make sense?
And this should only affect the manifest format. The information model should be agnostic for us.
Right.
Agreed.
Hannes is coming back to the mic.
But it seems, at least on that issue, it's from the folks in the room, and there, of course, there are other people on the mailing list, but there was a preference more to on the map side rather than the array side. At least that's how I understood the discussion.
I would note that Python.
Who are you, Dave?
I'm sorry, Dave Kemp with Department of Defense. If the information model says that you have an ordered map, that is, then you require a serialization that will preserve that ordering property. I'll notice that Python just recently decided to make their maps have an ordering property to it. So Hank says, well, you could use a two-dimensional array, but a map is a map. Well, if you have a serialization that preserves a designated ordering in your map, then you can use it. If CBOR does not provide that, then you implement it so that it does.
Rich Sauls, so one lesson learned from the old XML schema days is if the ordering doesn't matter, just pick one, and then you get the canonical form, and like I said, doesn't matter.
That's also a lesson from the ASN1 days. Since we have like 3 different ways to do it, we learned that's bad.
Yeah, I wasn't going to go that far back.
Right. So I heard 2 related but separable discussions. One was on map versus array, and one was on ordered versus unordered, right? Because if you have a map, it could be either, right? If you have an array, it's obvious that it's ordered, right? And so I said that map versus array doesn't impact the information model, right? Ordered versus unordered could be said in the information model. If we said it had to be ordered, then the information model could say that if it had a reason why, independent of any serialization format or any data format, if it needed to be ordered, it could say that. And I saw some discussion on that I heard people arguing, yes, it should be ordered, was what I heard.
What I heard was the reason the ordering was important was so that everybody does the signature the same.
Actually, I was going to add to that. I heard that we need to at least discuss and define where ordering does matter within the information model, which I think is something that the group needs to do. The other thing that I would say that we should prioritize is documenting these concepts in the information model even before we focus on any additional updates to the data model, because our goal is to ship the information model, sooner than the data model.
If the edits were being done by different people, there's no reason that they couldn't be done in parallel. But if they're done by the same person, please prioritize the information model updates between the two.
Yeah, this is Hank again. And if you're really invested in having an ordered map, you could, in theory, register a CBORD tag for that. There once was a effort that planned to introduce a CBORD tag for a ordered multi-map, that even though the members won't be unique. This is of course not necessary here, but
of course unnecessary.
so but in theory, if you're really invested in this, you could attempt to register a CBORD tag for that and see how the ISG likes that. If it's really
an ordered multi-map would give you one advantage here, and that's that you could essentially turn the entire thing into essentially a bytecode interpreter.
Yeah, all the multi-maps have other issues. So there's a benefit to it, this is what you said, but they are also very messy with respect to consistency and redundancy and infinite and whatever. I mean, there's a reason why Jason didn't do it, and there's a reason why CBORD still doesn't do it, and people abandoned the idea. So
yeah, no, I'm just saying that that's kind of a cute use case for it.
I just want to highlight the option. I'm not for it, but I'm for transparency, so I highlighted the option.
David Brown in queue, or did he drop back out?
I can't tell.
I can't tell because the presenter started live. I'm going to push the button. Hopefully this doesn't disconnect you, Brendan, just to see if David's in queue. So
okay.
David,
Hey, it works.
And I still see Brandon. Great.
Hey, there we go.
Just wanted to point out, I think there's probably two reasons for constraining order. One is serialization or signatures, which I'm not sure is actually important for this case, since you're always signing a specific manifest, it's not a signature on something someone else will be generating. But the other reason was the argument of making poll parsing easier, that if the ordering is specified correctly, the processing can always be done in order. One thing I wanted to point out, I brought up on the mailing list, just to make sure we consider that these processing steps may have different actors that will do subsets of them. I don't know if we want those as separate processing blocks or how exactly we want to do that, or if that's addressed.
I think the way that this would address it is that each successive actor would define a new process tree, which would define what the recipient of that process tree needed to do. And if the recipient is another partial processor, they'll have to, again, define their own manifest that does the same thing again. This can get pathological, of course, if these are all signed. But I guess the question is, how plausible is it that we get multiple levels deep in that kind of a queue?
Yeah, I envision maybe 2, not 30.
So parsing 30 manifests is probably not a good plan. Parsing 3 might be difficult on a constrained device, but doable.
And David's reason for summary of the ordering reason was the one that I had heard that I was referring to. So, all right, go on, Brendan.
All right. Well, it looks like we've got some time left, so I can talk about some of the current changes that we've got in place. These are things that were in the draft that was submitted, not things that are open. So the primary structure is currently an array. We may have to change that. Text is severable, which means that we can cut it out and deliver only machine-readable data to machines, which I think is an improvement. Multiple payloads are allowed, which was one of the requests from various meetings and mailing lists. Resources were separated from assets. So resource is the thing before it's installed, and an asset is the thing after it's installed. We can work on the terminology if you don't like that. I'm not tied to it. Description of the installation process goes into the manifest. Conditions were divided into preconditions and postconditions. We've added the component identifier, which replaces the storage identifier, and the timestamp has been removed and replaced with a sequence number. So this is pretty clear that there's still ongoing development. This is still a work in progress. Next slide, please. So severable text. Text is for humans. It's not used by devices to make decisions, or at least that is the guiding principle of the severable text concept. If there is some kind of text that's needed both by humans and devices, this proposal would mean that you'd need to duplicate it. So devices typically don't need to receive text. These are IoT devices, but it's still needed in management systems. Next slide, please. So the way to deal with that is that we divide it into two pieces. First, there is the authenticated manifest, which is the container that has both an authentication, a COSE authentication block in it, be it signature or MAC, and a CBOR text map. Now, inside that text map, there is the map of keys to strings. Next slide, please.
David is in queue. Do you want to stop?
Oh, yeah, go for it.
I just want to point out, when we create this new top level thing, as well as our lower level things, are we intending to create a CBOR tag, or to allocate a CBOR tag for those so they can, the type can be identified?
Yeah. It would need to be, yes.
Dave Waltmeyer is coming up with the mic, so hold on.
Dave Waltermeyer, as an individual. I'm an author of another draft in SACM around COSWID, which I think we briefly talked about in some earlier working group meetings. That's a draft that's actually really targeted towards management systems and providing a lot of the human text that might be used in those management systems. Perhaps we might want to investigate how we could use COSWID to provide some of these more human-focused capabilities, leaving our work around manifest to be more machine-oriented. Would you?
That sounds like a great idea to me.
Hi, this is Hank. Also, as this came up, a author of the concise software identifier draft. We have had a resource collection edit that was dealing with defining firmware for 1.5 years now. And we decided to detach that resource extension and sell it to Suite because it's more suitable to have that firmware stuff here, I think. And I did that tonight. So it was a very short notice. I didn't bring this up. Basically, whatever we had read it before now. So maybe at the virtual intro. And this is based on maps, basically. And so now I didn't see this turning of events that this will be actually favoring maps. So that's great. Maybe have a look at it, and maybe we can find some compromises. It's merging the so on.
This is Hannes. I was wondering, like, Hank, question to you, like your co-author of the information model document. So it feels a little bit strange when you suddenly overnight work on some stuff and put it out and then say, oh, maybe we should cooperate when you're actually the co-author.
Yeah, that's my problem was there was such a strong disconnect between the data model and things Brandon just explained. I couldn't just use the information model. And also there was a need to do this for SACM because we're SACM on Friday. and we want to move on with CoSwitch, and the fireware, the firmware stuff really was basically holding us back. That was never gone through the last call in any case. We had to cut this out in this iteration, and I had to put it somewhere. And so the most obvious solution was just to cut it out right now and put it here. It's not even adopted. I mean, it's just associated floating around. So it's an individual submission. It's just in this context. And I think I indicated this last two suit sessions also redundantly. So this should not be a surprise that we were cutting that out and bringing that here, because I think I advertised it already last year. I hope everybody somehow got that. If not, I'm very sorry.
So inside the authenticated container, so that's inside the manifest itself, the text is authenticated with a digest. Or potentially the CoSwitch block is identified with a digest. And that is about all there is to it for severable text. Onto multiple payloads. So payloads have three components: a resource identifier, which is to say exactly where to find the thing, installation instructions, and with that can include cryptographic info when it comes to decryption, and the asset description, which is the size, the location to store it, and the digest of the asset. So what we've done here is split payloads out into multiple parts, and at the same time allowed for multiple payloads to be used. We needed an extension to this concept specifically for Delta and other advanced use cases. And what that did was it turned aliases, dependencies, and payloads all into resource references, which makes things a little bit easier. Assets are now separate from their resource identifier so that they can be overridden in dependent manifests. And installation instructions are separate as well. So the resources were separated from assets, which makes all resource separate references effectively the same. There's no need to distinguish between an alias, a dependency, or a payload. Resources define a local or a remote input, either a URI or a local or a remote input in the form of a URI and a digest. Assets define an installed image, which is the size, the digest, and the location. So due to some discussions on the mailing list, particularly with Frank and Ovind, sorry if I pronounced that wrong, from Nordic, in particular, they had a requirement to be able to check some conditions after installation. Now, specifically, that was some kind of digest or a custom condition, which we haven't elaborated on yet. I'm not sure quite what goes in there. Some obviously need to be checked before installation. So there were two choices here. We could make two lists of conditions, or we could duplicate condition identifiers to specify that some are preconditions and some are postconditions. It seems like separating it into two lists is the right choice because, again, as with the pull parser concept, it makes it quite clear for the device exactly what it should be doing at any given time. And with the duplicate condition identifiers, that would not be the case. The device would have to process that list multiple times. And the cost for making two lists is not high. Next slide, please. The component identifier has replaced the storage identifier. The storage identifier was not necessarily adequate for all use cases. So devices can be aggregates with more than one processor with two or more different storage systems. And the component identifier allows for designating which storage system you're on. On top of that, storage systems and hardware components can be nested. So it seems like the component identifier really needs to be a list. And if it's already a list, then rather than having a discrete component identifier and storage identifier, we can merge these two things into a single list. I saw someone go up.
No?
No? Okay. Never mind. Shall we continue then?
Is that the last slide?
Is that the last slide? It might be. I think it is.
Yep.
All right. So that is where we're at on the serialization then.
I think chairs ramp up. I think that's the last thing on the agenda. So. All right, thank you, Brennan.
Thank you.
Dave?
You want to do the chair wrap up? We're calling Dave back, who's busy wrangling blue sheets out there. Where are the blue? Did you get all the blue sheets?
No,
tracked down? Okay, where is the other blue sheet? If you see a blue sheet nearby, point or hold it up. There's one. There should be another blue sheet out there somewhere. Over there. Okay. All right.
Anyone need blue sheets? You could pass those around. Okay, so today we talked quite a bit about a number of some changes to the architecture that need to be done, but mostly changes to the information model and manifests. So I think it would make sense to talk briefly about when we could expect those updates to be completed. So let's start with the architecture. When do you think you can have an updated architecture posted with the changes discussed? Next week? That would be great. And then information model? Probably more extensive, the changes.
Yeah, that's a little bit more, that's a little trickier because of the changes on the other documents. So so I think that would be more like probably if you synchronize that in September.
So I think we might want to also discuss when we might have a virtual interim, because it would be ideal to have that update done before then. It seems natural that we might have a virtual in mid to late September. How does that sound as far as timing?
Good for me. I was just I was just wondering about some of the other guys who are very active on the list, but just don't happen to be here in the room, and they would probably have some comments on the format as they had comments before. So that will so if we distribute some of the notes that we gathered today and have some time for the entire group to digest those, because some of that is obviously a little detailed.
Right.
And so if we then pull that stuff together into one or into the document beginning of September, maybe the second week of September, then we could have the interim meeting afterwards.
Yeah. So are there any concerns in the room with having a virtual maybe towards the end of September? Sounds like something that we can plan around then. Yep. So yeah, data model. So we talked about some of the changes that need to be done on the data model. Hank, you also posted a data model. So I would encourage the authors of both drafts to get together and to try to sync up on the differences that may exist between the two. Are you willing to do that? Can you go to the mic?
So hi, this is again now at the mic. This is Hank. The driver was well, announcing this over and over again, we are now in the state that will drive CoSWIT through working group last call, and we had to cut that out. And before I cut it out, I made it semantic equivalent to the current submitted data model, so that there is no confusion there. Why is this differently named? And that's so you will recognize everything. It's just in order in maps now, and it's not in the CoSWIT core draft anymore. It is now again cut out, and this is basically what I announced here twice already. So I hope it's not a big surprise again that I just did that, and it's no problem to consolidate it. I think because it is easy to map.
So what you did is,
especially if it's maps, right?
Yeah. So so is it what you did is you took the information model that Brendan presented and changed it from array to maps. Is that what you did?
No, actually, we had a map structure for firmware in CoSWIT for over 18 months. And we started to align more. The suit formed, and we saw, oh, that's about firmware, that we should maybe wait for them. And then you do the manifest, the data format. And this all took a lot of time. So we aligned with that, but we never aligned with the information model. That's very new. We always aligned with the data model because it was very easy to align with. It was very specific, and also in CBOR, as we are as the CoSWIT. So that's why I did not use the information model to create the or to update the FEMP extension, but I used the current data model because it would be easier for people to compare them. Yeah.
The current data model that Brendan presented is brand new. It's was published in 2nd of July, and so that's what he presented back then. Now with this, in the meanwhile, we made already some changes. So I don't see if the contribution is should we use maps instead of arrays, and that justifies the publication of the document. That's fine, but I don't understand the relationship then and the working group last call with CoSWIT and so on. It will most likely change again as we are getting the feedback from the guys. The difficulty in this is not the decision about area or maps. I think that the more time went into discussing on how the whole structure looks in the first place, because different people had different use cases, and trying to encapsulate all of those was sort of complicated.
Yeah, that's why I used a very fresh one. That's in right now. And the difference between the manifest that is there and will now become a map, as I think, and the one that I submitted is that the one is tailored to be a resource extensions to concise software identifiers. So they are embedded in software SWITs, in CoSWITs. And the manifest cannot be just embedded in CoSWITs. And as I think someone highlighted before, there's a lot of benefit to use CoSWITs because there is this textual representation for humans already that can be detached from the other stuff. And the other semantics, like the supersedes, patches, or obsoletes, other things is also already there, and entities, and I mean, everything about software is already defined. And then we don't have to reinvent that maybe.
The difficulty with this work in the working group, I believe, is will ultimately be to get those companies who then need to make the changes to their code in the discussions. That's the difficult part. It's whether you can reuse some existing snippet of a few text lines. It's great. It's great if you can use those data structures, but that will not make the difference. It will make a difference whether Nordic Semiconductor, DI, Infineon, etc., see their use cases represented and feel comfortable to put that into their bootloader. I think that will make it the difference.
Sure. Dave Waltermeyer, as an individual contributor, I think the desire with CoSWIT is, there's some historic work in this space that's been done there. We'd like to see some convergence between that historic work and the work that's going on within this working group. So, to some extent, Hank's draft is a starting point in which we can maybe drive some of that convergence, going forward. I believe that that the Coastwood draft represents a good path forward as far as representing some of this management information. There's some adoption of a closely related specification in the industry already around an XML-based format, which Coastwood is parallel to. So I think it's worth exploring whether, for management use cases, whether that Coastwood might be applicable here. I think we could arrange a presentation for the virtual interim to maybe explore how Coastwood might be useful to satisfy those use cases if there's interest in doing that. And I think Hank is interested in talking about some of the improvements that he's made to the manifest model as well. He's fixed a number of issues.
But I think that Brandon also fixed them. They're not just submitted yet. So I think that's not an issue actually.
Sure.
At least that is my impression. So no, the thing maps are in there because Coastwoods are basically hierarchical maps. So that's the only reason why I use maps. So, and also again, I'm surprised that this is a surprise because I actually really reiterated it a lot. So sorry, if I heard, please don't do this here or just stop with that, then I would have done. I'm sorry if they disrupted any processes by that. Yeah.
Okay, so so I think this is, yes, Chair had back on. So I think we have some issues to discuss relating to the manifest. It'll be helpful to get an update of that draft out in early September, and then I think we can talk through more of these issues during the virtual interim. Yeah, Brendan, does that timeline work for you?
Yes, that timeline should work for me.
Excellent. Okay, so we'll start to coordinate on the list around scheduling. We'll probably put out a doodle poll to try to narrow down some dates for the virtual. We also have taken an action. We need to add the information model as a milestone. So we'll work with the ADs to get that milestone approved. Is it the architect? I'm sorry, it's the architecture, yes. Any other actions that, okay, so with that, any other comments? We can do open mic for a little while if there aren't any other comments or questions. Hannes? So close.
Question, yeah, sorry about that. I was wondering whether some people already know whether they are planning to be in Bangkok and planning to attend the hackathon there. I don't know if people make their plans already so far in advance, but it would be good to see a show of hands to coordinate with some of you. In case you know, it's actually a pretty good number.
I see 5, 6 maybe.
Yeah. Some of you going to participate at the hackathon as well, not just at the IETF meeting?
Yeah, sure.
Hey, me. Yeah. No, but now I see a different number of hands.
I do. So raise your hand if you plan to attend the hackathon at the Bangkok IETF meeting.
Yeah.
So
about
do you
5, 6 hands.
Would you be interested in attending the Suit hackathon? Raise your hand.
Yeah, I see. Yeah.
So I'm seeing maybe 4 or 5.
Yeah.
Some hand waving.
Oh yeah, and also maybe we should organize also remote participation. That worked pretty nicely last time at the Berlin Hackathon. I was surprised how many people were remote.
If you're interested in remotely participating, would you raise your hand? I see a couple. Okay, so that's maybe something that we should explore then.
Post it to the list and then figure it
Yeah.
out.
Sounds good. Hannes, anything else? Okay, I think with that, we'll conclude the meeting. Thank you all for attending. We'll see you in Bangkok, hopefully. I'm going to be on vacation starting on Friday through the following week. So my first availability will be the week after. Of course, I'll be getting back in And I'm happy to review it from there. Finish up Okay. So we should probably make a goal then of having them done within 2.5 weeks.
We should have it. We should have it out to people to review in 2 weeks for them. Even, otherwise,
Yeah. Well, especially given there's a number of actions that
Right.
need to be addressed. So. Okay.
Just
Um,
want to
and-
have the
and-
same thing happen.
And who's doing the SAG report? I think it could be brief, probably. I'd be happy to write something. I don't think
We're making progress.
Yeah, we're actually making pretty good progress.
It's like a decision. That's what I was.
And Ben ran off before I could ask him about the crypto question. Yeah, we need to. We probably need to have a conversation with them. Yeah, although we could have gotten away with it.
That was, remember I said, was not pretty much. So the question is, coming on the 30 minutes, stable.
That's right. And we'll have time to